Okay. Hey. Train plants every day. Jordan Scoville coming at you from the S.T.E.M universe here. I was thinking about my quantum mechanics game that I come up with yesterday, the A series, the B series, and when you continue that variable, or how you originally start that variable, you see a lot of initial fundamentals. A with A in the corner, and all the rest of the series. A, B, in the initial start of the series because they're both the same thing in the same place. You could say that for an example of what I want you to look for, more so than just what you could practice by quantum physics, is give me elementary physics equations. Now these could be algebra, these could be what an environment symbol turns into, or what that fancy E turns into. In a concept of what they are, and continue. I want the first homework assignment for that, or the first part of the game, is that you just actually physically computate all of those variables. See, that's the thing about a lot of this. Quantum physics is everything. There's nothing that quantum physics doesn't apply to, but the problem with it is it's that tree over there, right? And when generally we all know that tree's on fire over there, even though it's not. Right, it's just a tree in the middle of fall, just sitting there, but it's on fire. I could make a lot of things. I could put a lot of things next to that tree. There's things about the root when I go to dig things up over there that, that says there's molecular fire happening there, and if I don't calculate that, I'm going to get burned. So I'm going to light that bush on fire with my mind, essentially. And again, don't get too preachy with it. A lot of times that's, again, just another element by an element that creates an element in a state of chaos if you're not paying attention to it. There's the reality that you got to get good with, and we're going to build to that first. But it comes in the form using quantum mechanics, quantum physics, by this idea. The first, what we have to know is the ideas of what algebraic symbols are these? Is this A and all the series across, and AB and the AB series into C, or one position inside of those that are relative, where AB equals BA? Sure, that's a great example. The whole entire series of that thing sums down to those points. Great. Awesome. The same calculations and computations where 4 numbers are the same series as having 9 series in it. That will continue out to a point beyond that. Depending on where you cut off the geometry is your right answer. See, again, I'm not really particular as a direct physics teacher in theory here about what that homework assignment is working for me. Does from what I assigned it. I already understand that this is very open. That I'm not going to ask you to solve what X is when I know that there really is no answer for that unless I give you all these special relativity variables. And when you look at algebra, and when you look at physics without chemistry or without some level of special relativity to apply with it, you just have somebody doing the basic mechanics that definitely has an answer to the specific form. And with algebra and stuff like that, those answers go out the window, because when you start seeing A, B, and pluses and parentheses and multiples, and you really understand your physics apps on your computer, the physics formulas or the physics apps or equations or all math formulas on your smartphone there, you're going to start to see a lot of things. A lot of these things equal 0. Well, all of those forms in A mechanics there about how you're processing this information equal nothing. They don't equal a damn thing other than a fun little game of time killer. A distance of how far you can take those computations and not overlap the symbols. Where you position them in one case, because some student could have done the exact same pattern as you, except for the fact that where they broke it off, but the same numbers of groups would have remained and all the same symbols would have remained. So a different pattern relates to a different concept, but exactly the same. All the same parts are there, the same numbers, the same mass, the same density, but a different order that they could choose. And I'm not particular about that. So you'll have to ask yourself later, the A series and the B series, because you don't really need A. That's just this idea, fundamentally, of what Planck looks like. The A B in the same order in that start position where I'm not fucking around with A in that B series. To start C is 4 positions, and then you could continue off of that, and it's almost impossible to see that you've walked through a wall. You know, some people say, well, it's impossible to get through that wall, and you're right. And it's again this A-B game, and you have to explain that to people. So again, what this practice does was it gets you comfortable with forming nodes. It gets you comfortable with a scale problem that you may not understand. And that's going to help you in direct physics later in life when you start to apply this to your small business, whether it be landscaping, carpentry. This is going to be a form that you have to draw out. This is going to go to that job for that small business, for that factory, super large, a government, these forms. A lot of people have problems with what I find psychologically, of course, and again, this A-B game, but how often do you actually process the numbers that don't really have numbers? You know, the size of the materials you have, to backtrack it to figure out what the first move of a thing that you can do based on this fractal or this decimal point or the percentage of resources you can really use, you can really handle, understand. Very unstable, and it can be absolutely crazy when you're me, when you study this material and you're trying to go up against this wall. You know, at the end of the day, they're using real elements and things like that, and they're going to break that all down to a practical level. The geometry that they're going to say it has to apply to is this atom of an element, and they crash it together in something else to better computate it, to remove all this gravity when it's shooting down a hadron collider so that it hits perfect center mass. Basically, I here remove diversified inconsistency from what I already know. So you look at that company you have, you look at your home life. How do I reduce diversified inconsistency? By adding something to it. It's going to create a momentum problem. All of those great answers are in there, and it takes a long time to get used to it. You're going to crumple up a bunch of paper, make a bunch of mistakes. You're going to look at that landscaper's map, you're going to look at that checklist, you're going to look at that inventory, and basically what are you doing? You're processing computations of patterns of the state that's in this given universe. On that game, there is no limit except for your imagination. And you'd got to understand, there is no limit to that business. But in this time of this size of the group, we'll call it ABC, just to process everything in there, it can be just as difficult. A, B equals B, A, G. Be a fucking general of relativity. So I want you to get good with those. And again, later on, we're going to actually build this out. We're going to start with a frame. We're going to say, well, what the grid needs to be is not this 4x4 grid or equal to this 1x1 grid, but here's a stone dock. That's your first A calculation. Here's your point in the stone dock in X. That point in the stone dock. Here's just burning stone. Here's just a customer service position in a hotel. Here's a dollar store, and you can be a quantum physicist. You could be a manager. You could be the fucking man. Now, those are your elements you're dealing with. You're going to crash that into other people. You're going to crash that into the wall. Stock, inventory, cleaning, because at the end of the day, somebody may not understand cleaning and how important is a calculation when you run that through the Hadron Collider here, the daily operation, what kind of gravity it presents, what kind of numbers algebraically it represents, what kind of process scientifically. Just cleaning is cleaning, but when I run that, what other free radiant energies are around that? Well, it makes your store look better. That makes you look better. That gives you higher general relativity. That gives you better gravity as far as your store, your point inside of that store, as far as the composition and the density, the mass, the volume, the acceleration. Some things seem stable. They seem stable within the frame that they're in. You don't want them to go faster right now. Too many other things say that they're not. But it's always going to be good to bring more stock into that store, to weigh more. Now, again, are you in charge of this? This is going to be one of those things in life. But you have to ask yourself, If I knew all these extra numbers, what's stopping me from being a quitting and being a quantum physicist? What's stopping me to being a teacher of economics? What's stopping me to be a teacher of applied physics? I know all the variables, I know all the things, so I'm going to go do something else because it's a higher standard thing. What's stopping me from taking those jobs and then just quitting it out to find another stable one that's in this system? Now, all those other ones are unstable, all of them. Again, it's one of those things with this answer. There really is no great answer that sums it up. What is the meaning of human nature? Let's get it wrong. It's to apply in this. It's to try. By terms and the reciprocating systems, all of those answers fall short still. It's still unstable here. So whether it be roads, Fermat's Beals, a divergent, a divisible, an integer, a real number, a complex number, a composite system, how they apply in two states at once when I'm trying to pull out what an integer is, a complete system, or what is it called? It's got the lines around it. A complete number, I think is what it is. Right offhand. But use your apps. This is the complete system, AA. This is all the series of AB. In AB of a form starting with A locked in an A position. Those are complete systems. Those are complete models. They're highly composite in the model that there's a lot of points to them. That they all fall to a multiple model. That can be your system. And if you actually apply that mathematical symbol to it, the actual equation that references that, you'll get an A in my class, because that means you studied the material. It means you understand it. You give me a special relativity state that goes with it. That's 3 points. You give me the time and places that divide that down to special relativity to say I can make x2 and y3, or x plus x3 plus x2 at this point in time in the fifth dimensional calculation. Because time at 4 doesn't matter. Stone die, bluestone, limestone, could be a board factory. It's still a space-time, time-space problem. But now we're getting more in-depth to those special relativity calculations, back to quantum physics and everything like that. Again, that's just number theory of this binary system. One of the things that's wrong with this is you have to get past this way of thinking about a thing. General relativity, talking about 3 dimensions and how we perceive them around us all the time, may not be right. This thing is XYZ when I separate it. Hand on the wheel, ass in the seat here. But they tell us that the quantum gravity doesn't get to general relativity without crashing through a wall. So how do we smooth that out? By saying, well, we can build to this system, but it's always 0, 1. It's always, left, right, up, down, X, Y, Z. We're not taking in consideration some of those other calculations until I can specifically call it something. Then it has 2 dimensions between A to B again, 0 and 1. And I'm going to give that a Z dimension, a depth, a height, a width. The total number of particles I'm shooting in it. How many atoms actually are in this volume problem. I'm going to shoot that down the Hadron Collider. That's one of my favorite. I love it, but I love to hate it a lot of the times because, I study a lot of this psychology, and it's one of those things, if you can't find, again, the 0 inside of it to make it something extra, just pull energy out of the universe here to make it better than what it is, this stuff can absolutely eat you alive. When you study the apps and stuff and you look for a master series to actually have to apply what the first A is, and the second A, and that third A, and that fourth A, and you have to make that make sense in Newtonian order, the universal field theories out there, whether algebra, trigonometry, physics, you'll find that there's lots of answers. And you'll find that when you go to the next step, they totally shatter the way of thinking about it because I need it here and here and there and there. And it's a very psychological in the nature. It's analyzation. What's physics? Analyzation. We're breaking this down as much as building a bridge with it. And, it's all social liberal group stuffs as well, based in psychology. As a scientific community, we all have to agree with that's what we're going to call this. Otherwise, it's not going to be stable enough to ever take form. And I see a lot of crazy in there, and I don't like it all. So, help me out. Do your homework. Catch you on the next one.